Spatial, the podcast where the real world meets the digital world as we explore the intersection of spatial computing and AI. Let's welcome our host, Andrew Ballard. Over to you, AB.
Well, g'day and welcome to Spatial. This is episode 20, joined by a special guest this week. I have Phil Delaney with me. Phil is, goodness me, wearing many hats. We'll find out exactly which hats he's wearing today. We know one of them. I was intrigued by Phil's LinkedIn post a couple of weeks ago. He is CEO of the newly formed organization called MapAI. And yes, dear listeners and watchers, you can tell that I was intrigued instantly. Phil, welcome. Great to have you with us. Awesome.
Thanks for having me on.
Look, your history is wild and varied, and I say hats is probably not even the correct terminology for it. Is there a plethora of many hats phrase we can possibly put on you? But by all means, can you introduce a little bit about yourself? Tell us a bit about some of the hats you kind of wear right now, and no worries.
So I guess I wear two main hats at the moment. One is as Deputy CEO and Chief Growth Officer of Frontier SI. Frontier SI is a social enterprise that's been around for about 20 years, and we really sit between research, government and industry to help bring interesting ideas through to real-world products and services in the area of space and spatial technologies. And then through that, one of our recent innovations with our partners at University of New South Wales has been to combine generative AI and spatial analysis. And so through that, we've created a subsidiary company called MapAI, and I'm the CEO of that as well. So I spend at the moment about half of my time with each of those two roles.
Wow. So we'll tell you what, we'll leave MapAI for a few seconds because that's going to be a large tangent without fail. Frontier SI. So 20 years of a social cooperative. Can you explain what the brief has been there, some of the projects you've been involved with?
We were formed in about 2003 and originally funded under the federal government's Cooperative Research Centre program. So that's a program that's been around for a really long time that looks at funding collaborative innovation in a whole lot of different industry sectors, everything from hearing to pork production to mental health. And so we were funded as a centre to focus on spatial information. We had two rounds of funding, one that went for 7 years, one for 8 years. So that covered our first kind of 15 years of operation. So we were funded through a government program, but that covered some of our funding. More than half of it came from contributions from industry, university, and particularly government agencies. We were a CRC for about as long as you can be under legislation. And so at the end of that, the thing that our partners valued the most, even more than a lot of the solutions that we'd created, was the model of collaborative problem solving that we made available. So we're now coming up 6 years at the end of June, which will be 6 years since leaving that program, kind of standing on our own. I'm still looking at a similar mode of operation, but we do a lot more of the direct problem solving ourselves with some internal technical capability and specialists, particularly in the area of precise satellite positioning and in satellite image analysis and other image analysis. But we still very much work through that collaborative approach where almost all of our projects have some combination of government, industry and academia working together to solve major problems that use space and spatial technology.
Oh, brilliant. And look, I need to mention, you're also a local lad. We're both this side of the Southern Hemisphere in sunny Australia. Granted, it's sunny as of this day, but it's cooling down. That'll give us some place when we're talking federal government. We're talking the Australian Fed Gov. Love to come back to that concept if we have time of the global positioning satellite in Australia.
Yeah, sure.
The acronym is definitely new for me, so has escaped me. But I know that has a lot of headway also around this part of the world. So I'd love to catch up with that. Gotcha. So Frontier SI had 15 years of fully funded CRC, and then the last many years it's evolved into carrying forward that model in a perhaps more traditional commercial kind of bet.
Yeah, I mean, so we're a not-for-profit organisation, but we like to describe ourselves as a social enterprise. So that really means that we use very commercially grounded strategies in order to make a substantial difference in social, environmental, and economic outcomes. So as a not-for-profit organisation, we don't have shareholders. We do run a lot of projects that cover a really wide variety of work, from independent advice that can happen anywhere in the world, through to that technology development kind of projects, and any surpluses that we make along the way through the projects that we run then get reinvested into creating new technology like MapAI.
Nice. Look, lovely segue. I think the Honourable Minister for his question, that's a sitting duck for us. MapAI. So the big announcement was 3 weeks ago. Can you tell us about how MapAI was formed? By all means, we have a teaser of what it is. Website we link in the show notes. If need be, we can do some screen sharing and I can talk to it for those listening in with headphones. But can you tell us about MapAI, its purpose, its future, and where it sits right now?
Yeah, absolutely. So, like I said, we've had a long history working with research teams to try and take ideas through to real-world products and services. One of the universities that we have a long relationship with is the University of New South Wales. And last year, as part of just the regular discussions that we have around finding ideas, they'd mentioned that they were kind of noodling around with ChatGPT and trying to investigate its spatial capabilities, and had seen certainly some good ability to translate someone's question into code that we could execute, but a lot of the understanding of the nuances of spatial information and why it maybe requires a little bit more special consideration than some other types of data meant that we saw a good opportunity to create some fine-tuning on top of what at that time just ChatGPT was doing in that conversational AI, large language model type work, to see whether or not we could get a working prototype that would answer questions in a bit of a different way. So,
lovely.
I guess
so using the large language model as the language model and query language and chat, but the problem normally is with the spatial world is people don't have the vocabulary to know what they can ask.
Yeah,
so
that's right.
Was this the layer that lets people ask deep, dark questions and have sensible prompting?
That's exactly right. I mean, I think that what we were really trying to do then, once we made that first connection that let people interrogate a single data set, was to say, okay, great. One of the biggest things, as you say, that inhibits people better using the insights that they can get out of location information is that they don't know what questions to ask. They don't know what data might be required. They don't know how to translate between the raw question that they just need answered and what that might mean from a process and data perspective. And we wanted to try and, absolutely not for every application, but for a lot of kind of simpler data sets, well-structured, well-understood geospatial data where people have regular questions, we wanted to be able to create a chat-based interface where someone could just type a question, and then the work would happen in the back end to create a query automatically that could be executed and would either respond to that user with a text response, some kind of table showing the information, or, of course, a map.
Brilliant. I mean, that is. I think where the future is heading. I know we had a chat in our last episode where I think the tools of the future will be less fingers, keyboards, mouses. It'll be a good microphone and a glass of water. I think our voice boxes are going to get slightly hurt during the next couple of years. I'm always reminded by the Hollywood scenes of, when someone is talking to their AI, chatbot, whatever. It kind of makes perfect sense when it's one-to-one, but I can't foresee an office full of 100 people all talking to their computer at the same time. I think that would be like, I guess, a phone call center, but without any end customers. So
that's right.
there
And
needs to be-
I think the other complication there is that we can often type faster than we can talk. And the other great thing is that we can edit before pressing go, which is still something that we
Absolutely.
haven't managed. That real-time editing of the question that I'm trying to ask via voice hasn't really got there yet.
No, there's no such thing as backspace, backspace, backspace in vocal terms yet. No, I'm sure if we do the voice dictation, it'll be no, damn it, hang on, wait, stop that, no, no, yeah, stop that, pause, please, yeah, no, fair call. So MapAI, it's cloud-based, it's going to be local-based. How does it interrogate data sets? You have to introduce it specifically, or you can marry them together.
So the way that we've planned MapAI to work, we figured that there were enough platforms out there, whether they call themselves geospatial or not, there are enough platforms out there that have location-based information that we didn't want to introduce yet another platform to the sector. The way in which we want to work is to be a white-labeled solution that integrates into existing offerings that really creates a chat layer between a user and the data that a platform is already managing. So as MapAI, we don't want to be a UI company unless there's a big gap. We certainly don't want to be a data management company. The idea behind what we've got is that the data stays where it is at the moment. The platform stays where it is at the moment. We just add in two new layers. One is a context layer that helps us to describe what data we can interrogate, and the other one is a question and answer API that feeds the questions from the user to us in our cloud environment, and then we feed back the code that's required to then answer that question for the user.
Nice, brilliant. Look, that's very smart. No one needs to reinvent every single wheel, and interfaces alone are perilous and large.
And expensive.
And that they are. And if you can get away with, again, having the microphone at no interface, that's a great option. But I also, same with last week's chat, an interfaceless interface, how do you tell someone what they can ask? How do you prompt the user in those early stages to do some either training, learning, or exploration mode?
Yeah, that's a good question. And the way in which we're doing that at the moment is by focusing our early proofs of concept on quite defined applications. So rather than a free-for-all, come and ask any question of all this data that we've got, we've got a defined application, which is, for example, a customer service team inside a council, or an asset owner trying to forecast where there might be demand for new types of their assets in the future, and having a very defined use case, which is only about asking questions along that particular problem.
Yeah, brilliant. So the users, they may not be completely across all what they can do, but they at least the data set is home turf for them. They are already across what its purpose is, its intent is. This just introduces them to new ways of actually finding out what's next.
Yeah, that's right. I mean,
queries.
I think that it's easy to get carried away with the potential about where this might go in the future, but this is all still very new. So our focus has been, at the very first instance, just trying to test whether or not the large language model actually answers questions in a useful way. And so to do that, we want to make sure that the scope and focus of where our first deployments happen are really clear.
Yeah, makes perfect sense. So you say you've got a fine-tuned layer on top of ChatGPT. That by itself is reasonably groundbreaking. It's pretty darn hard to do any fine-tuning on large models. How did the team come to that conclusion, and how did the team tackle that? And was that a lot of seriously supervised training, or just exploratory work to actually be able to find that extra layer to have that command set active?
It was a bit of a combination of both. And the other thing that I'll say is that we started with ChatGPT, but the way in which we are deploying our fine-tuning model is as a middle layer that can work in between a user and any large language model, be they the ones coming out of Amazon or Meta or some of the open models that are out there at the moment as well. Our aim was to provide a fine-tuning solution that could be large language model independent as much as possible. That way we could integrate with any solutions that people were already using from a large language model perspective, but would also mean that we had the flexibility not to be locked into a particular large language model solution, as we've seen happens with many large corporations. As they get kind of more share, they can then do what they want with kind of pricing and usage and that kind of thing, and that can cripple a business that has a sole reliance on one model. In terms of the way in which we go about creating that fine tuning, I don't want to say too much, mostly because I'm not the technical person here. But what I can say is that we have a whole range of question and answer types covering a wide variety of potential spatial concepts and spatial questions, and then start to look at how we create pairs or multiple matches between what a question might be trying to ask and what the spatially appropriate method for answering that question is.
Yeah, brilliant. No, perfect. Look, love the separation of powers of large language model of choice. By all means, if you started this concept late last year, and here we are in, well, we'll call it May, but actually it's the start of June by the time this episode comes out. It's been another few epochs, even this year, of iterations of not only the large language models, but even the fast following, the Hugging Face open source world of student-teacher decimated local models that have, sure, they're a few percentage points down in terms of efficacy and brilliance, but they're local and mere mortals like us can run them on pretty beefy computers. So this does open the door now to not having to even be reliant on the big four, the big five out in the cloud. Is there a mode in the future, he asks inquisitively, for local versions of this kind of tool?
Yeah, definitely. I think there's two approaches to that. One is the co-pilot type approach, where you've got a ring. Nice. It's still all based on a cloud solution, but one that's ring fenced to an organization's kind of cloud tenancy, so nothing needs to enter or exit the fence that's around what an organization owns on the cloud. And the other one, certainly a little further in the future, wouldn't want to put a date on it, but we absolutely talk about it, is the ability to have a model that can be deployed, cloud-based, server-based, even, powerful local machine-based, as that pair between our fine-tuning and a locally deployable large language model.
Yeah, no, that's spot on, perfect. I think the pendulum is going to swing from let's go cloud and let's find the value and the power of these tools to, okay, now it's great, but we're now racking up not only, queries, but we're racking up internet traffic in and out to get our data in and out. There's always the question of where is my data? I don't know whether,
and what are people doing with it? Yeah.
Yes. I imagine you've met the kind of people in your past 20 years who still want to see their spinning hard drives and LED lights flashing in a server room somewhere. I dare say those kind of people are not multiplying, but
no, they're certainly fewer and far between.
There are still many fields where I want to know where my data is.
Yes.
No, that's quite perfect. Can you give us like a use case of the kind of spatial queries that MapAI can help with? I mean, pick any of your potential customer bases, but what are the kind of unknown unknowns that MapAI can reveal that you can do that mere mortals would not really know how to do unless given this kind of tool?
So I want to start by saying that nothing that MapAI does is something that can't be done by a mere mortal, as you phrase it. But what I would say is that a lot of the work that it does is trying to alleviate a lot of the base work that, say, our very busy, understaffed GIS teams might be doing, responding to simple questions like trying to get a filter of a subset of data from within one data layer, or looking to find the addresses that are around a point, or just some relatively simple 1, 2, 3 combinations of data sets and features within that data set. to understand questions around, assets that might be a risk of flooding, or locations to target for a particular type of demographic profile. All those
Gotcha.
questions that are relatively simple, but in that feedback of I need to find an analyst, I need to wait for that analyst to be free.
Yep.
They will provide me an answer. I need to iterate that a little bit and then get back. That can take kind of hours, days, or weeks, depending on how busy a team is. The idea here is that for a lot of those more simple applications, we could just type in a question, look at the answer, then refine the way that we ask the question.
Yeah, beauty. Gotcha. So in the in the bell curve of potential queries, the dead easy ones are dead easy. The interface probably gives it to you. The other end of the spectrum is the gnarliest, biggest, deepest analytical questions. Probably reserve that still for the analysts to do the big, gnarly, multi-week. I want to find every single house that has, starts with a letter Q, where there's one dog and one cat. That's a query for someone who has more time on their hands. But that leaves the middle wide section of find me all the, how many primary schools are there within an X radius of this point, or refine this
that's
query.
Right.
Yeah.
Yeah. So the common, I guess, starts to a lot of the queries that go into MapAI at the moment are show me where
Nice.
is, find me, summarize, or display, something like that.
Yeah, gotcha. Powerful tools that are probably by definition the highest volume kind of things you'd like to know. Yeah. No, beauty.
Yeah.
Perfect. What state is MapAI in? Website, as I say, I'll allude to it, and again, link in the show notes, is a little bit. I think
a little bit light. That's right.
Three pages. When do we?
We're about 6 months into
Gotcha. Yeah.
MapAI development in terms of real. When you take out the Christmas break and all that kind of stuff in terms of the effort that's gone in so far. And anybody who works with the research world knows that often it's hard to get a lot of useful work out in a short timeline for that, particularly as the problems that we often tackle with our universities are pretty big and long term. Saying that, the team in the City Futures Research Centre at UNSW have done a really great job in continuing to release and improve a version that can be kind of deployed and demonstrated. And so it was only kind of 4 months in that we had a version that we could ask questions of. And while we don't want to be a UI company and we don't want to be a data management company, obviously to show that it works, we had to take a bunch of data. So a couple of months ago, we had a dump of a range of data out of the New South Wales government in Australia's open data website, things like planning zones and properties and addresses and roads and those kinds of things.
Yep.
And we described that and we put it into a simple user interface and then started asking questions of it and used that as a way to kind of refine how the model worked, the kinds of responses that it gave. And pretty quickly, we saw that even the version as it was then could provide a lot of really useful work, say for people that only wanted to ask questions that needed, 3 or 4 or 5 different data sets to be combined in order to be able to answer them. So we started to have a look at identifying a few organisations that we could then prove this concept with, even with this really early work out in the real world. So we have now, and I can't talk about it publicly quite yet in terms of specifics, but hopefully I will be even by the time that your podcast comes out, ideally. But we're working with a major data company as a way to integrate with a lot of the work that they create in terms of unique national scale data products and a way to query those in a brand new way. And then we're also working with 2 local councils, one for more of an external type application in helping to answer questions that come in from the community, things like when is my bin night, or what are my planning zones? Can I open a hairdresser at my address?
Nice.
These kinds of questions, and then the other one is more of an internal use case in supporting field staff to better understand the sites that they're going to visit. So
yeah, brilliant.
Even with this early large language model, you can see that with each of those applications, there's probably 5 to 10 questions that are pretty
predominant,
repetitive, but site independent, so that you need to answer them in a slightly different way depending on where you're going. And we can answer them using kind of a handful of data sets. So it's with those that we're now kind of rolling forward to demonstrate this in the real world. And having those agreed was our kind of prompt to then let the rest of the world know that MapAI existed.
Lovely, lovely. So we'll put in show notes or a extra update if the podcast and the video beats this extra news. But by all means, the show notes will hold the source of truth for the latest release of MapAI. Brilliant. Cheers for that. Look, just changing tack a bit, MapAI by all means is going to be the right kind of tool for that. Well, we're talking local councils, we're talking service-based organisations, those who already have spatial or a location bent. Can I roll back to some of the other things that are on your bio, which are quite fascinating? Map 4D, other sort of tools in that vein. I guess we're getting deeply into agriculture, farming, and the permaculture world. Can you give us a brief about some of the other spin-off companies and side projects you've had from Frontier SI?
Yeah, sure. So there's probably two good examples. I can talk about FarmMap 4D, and then I can talk about another more recent commercialization, which was for a company called Value Australia.
Brilliant.
So FarmMap 4D was actually, its original name was the Natural Resource Management Spatial Hub, was the reason why I was employed by Frontier SI in the first place almost 10 years ago. And what it was a collaboration between a range of natural resource management organisations, so, government-funded organisations that look after the environmental management of a particular region. Focused on the middle bit of Australia, the really kind of dry and arid bit where we have a lot of cattle grazing.
Big bit in the middle. Gotcha.
Big bit in the middle.
Yeah.
And the idea behind that was to take remote sensing data, so images from satellites where we have derived insights about the quality of somebody's land, and take that away from being just a tool used from government to monitor the performance of land managers into something that we could put into the hands of those land managers to help them better make decisions, right? That was the whole idea behind that. So it used a derivative satellite data product called fractional cover, or fractional ground cover that this was. Okay. What that actually means is that it simply takes a whole lot of satellite information calibrated to a whole lot of ground sample sites to tell you for each little square of your land over the last 30 years, how much of it is alive vegetation, dead or non-photosynthetic vegetation, or bare ground, right? Wow. So, and when you track that over 30 years, you can start to have a look at how sustainable is the level of cattle that I have in a particular paddock. So are we getting to the same level of green cover every year, or is that slowly declining over time? We're going to have a look at how the practices then impact on things like erosion. So as we're overgrazing land, that leads to a lot more runoff of the good soil on top, which goes into the streams and then in Queensland washes out into the reef and causes a lot of problems there. So again, this is about the long-term trends and helping people understand things like sustainable carrying capacity, erosion risk, and things like that. So
that's phenomenal. 30 years worth of data on this site.
So that was working on NASA's Landsat data at the start, and then using some of the European Space Agency's data from Sentinel to then enrich that for more recent time at a higher resolution. And it was run as a collaboratively funded project between a range of different organisations. But as all projects do, they come to an end, and people didn't want to see the end to the solution when project funding runs out. And so sometimes having that operate as a government service is the best way for that to happen. That's what we do with our positioning work. Sometimes releasing something open source is the best way to get it maintained. And sometimes putting it into a company is the best way to have a sustainably managed solution. So that was the case for the Spatial Hub, which rebranded then to FarmMap 4D.
Yeah, brilliant. Look, that is, of course, immense value to know such a long term. I take it at the start of the 30 years, your data points were fewer and further between, but to have that such a long term smoothing graph of, your bare earth is slowly climbing, and that obviously is things that people who are so close to the data on the land would kind of know, but also kind of not be able to validate or quantify. So that kind of tool to provide that independent.
Yeah, that's
chart.
right, and it's really a testament to the work that NASA has done in keeping the Landsat satellites consistent and regular over the last 30 years to allow that kind of long-term history. And in fact, while we were running that project, we were highlighted on the NASA News page as a great example of using their data.
Excellent. You were employee of the month there for a while.
Yes, that's right. Yeah.
Nice. To your other
so the other example, and this one was a bit more recent.
Large
so
acronym.
The stuff with what became FarmMap really went out into the private world in about 2018, I think, and is still going and serving customers now. A bit more recently than that, we did work again with the team at University of New South Wales in automated and interactive property valuation. So we ran a workshop a number of years ago with a whole range of, again, industry, academic and government people to try and find interesting problems where we thought that spatial data could play a new type of problem-solving role that it hadn't necessarily been doing so far. And one of the use cases that was raised by government and validated as a good industry problem as well was trying to understand when we do something new, major, like building infrastructure, like a train station, what impact does that have on property values?
Property valuations in local and
in the areas just around that. And if we can get away, so at the moment that would cost you hundreds of thousands of dollars in consulting time to try and do something, answer that kind of question. Is there a way that we can quickly and easily model what it's likely to be? Because that then plays a critical role in a business case for infrastructure, because as property values go up, that obviously benefits the community, but it also increases things like land tax to help to then fund that infrastructure.
Correct.
So
nice.
we did some work to try and work out what's required to make that happen. And the biggest thing that was required to make that happen was an automated land and property valuation model. We need to understand what the value is, but even more than what it is, why is it that value?
Gotcha. So the breakdown of the components of, the closeness to the primary school adds this much, or was it that discrete, or was it just
it was
the
absolutely
AI?
It was absolutely
gotcha.
that fine-grained.
Brilliant.
We get a lot of really high-quality data assigned to each individual residential property across Australia's capital cities, something around 10 million properties, I think. And it was a whole lot of data that was just kind of straight out of government databases or high-quality private databases, and then a whole lot of things that we kind of derived as well using, Geoscapes, building products to look at, the heights of buildings, all sorts of different things. That building then let us work out for each individual house, not just generically what might the value be, but for this house, what is its value and why is it that value? Because then when we understand why it's that value, that's when we can start to go about playing with future scenarios. So either for an individual landowner, maybe looking to say, what happens if I, should I renovate my kitchen or add a bedroom? What's going to create more value for my house?
Impact.
Through to the government looking to build new train stations, revitalise the quality of the local school, and the quality of the local school is a big driver of value. Access to open space, all sorts of different things. We then built a system that let people interactively, like SimCity, create that new infrastructure and then immediately see what the impact on property value was.
Swap out X with Y, drag, park, make it bigger, do the terraforming. Yes, that's
right.
Yeah.
So that was a great use and
beautiful.
And as well, the actual valuations model itself was not just useful for the governments, but also to banks who help to make our risk decisions about, mortgage lending and things like that.
This is the holy grail, actually, of spatial intelligence. Sadly, it's not quite the hello world. I think it's the first thing that everyone goes to see if they can figure out how much their house is worth. And then the way that you're doing it is the way to crack it, of doing it large and doing it throwing, I guess it's classically the data science way. you throw all the data at the problem, and all means you just throw the bucket at it, and you find
we had
out,
about 1 billion data points in the model that we were running.
ouch, and then that falls out what actually was relevant, what wasn't relevant. The number of cafes in 10 square kilometres didn't really matter as much as hospitals and primary schools and police and those sort of things.
Yeah,
Gotcha.
exactly. And we tested well over 50 different modelling approaches as well to work out which ones were both accurate and explainable, because having not just an accurate model, but one that you could talk about with somebody was also really important.
Very good. Yes, when computer says X, that's nice, but in this vital field, you need much more than that.
Yeah, that's right. So we put that out into a company 2 years ago, but we needed some people with great data about land. What we'd really built was the engine. We needed someone with fuel, and so we ended up commercializing the company with PEXA, who are the digital conveyancing company in Australia. For those not from here, every time you buy and sell a property, the transaction will go through PEXA's infrastructure. And so it really complemented a lot of the work that PEXA were doing, trying to diversify what else they understand about land. And so that Value Australia company has seen a great life growing as a commercial entity over the last couple of years as one of PEXA's family of companies. Yeah,
lovely. The digital marketplace is certainly a beautiful theory, and when one organisation can not only be the transaction hub but also be the value add, it's a bit of a slam dunk that makes a perfect marriage there. Yeah, indeed. Can we change tack one last time from acronyms and long project names? Now, I said earlier, I do not have in my head what this acronym or wording is, but the Australian uplift of GPS. Could you give us a briefing on that, your involvement, and where you see the future going?
Sure. So the generic name of the system is SBAS, which is Satellite-Based Augmentation Service, and Australia's SBAS is called SouthPan.
Okay. Beauty.
So that's
those will be in the show notes with links, because I will forget them without
no worries.
Cheers.
So what SouthPan is a way for us to broadcast from space a correction signal to satellite positioning like GPS. So there's a number of different constellations up there operated by different countries or consortia, like the European Space Agency, and every signal about positioning has an error that happens because the atmosphere changes over time. And so when we position ourselves on our phones or on our car's GPS or whatever that might be, we generally are only accurate to 3 to 5 meters, which is great to know approximately where we are in the world and what road we're on for navigation purposes.
It'll just be enough to get you what lane you're in, but that's actually about the limit.
Yeah, not even just the road, because 3 to 5 meters is enough to put you on the other side of the road.
Gotcha. Which would be bad.
And so what we needed to do was to work out a way to correct each of those signals. So what we have is a bunch of really well-known locations around Australia and New Zealand, where we know really precisely where they are. And what we do is we collect all of the signals from the space-based positioning and say, well, for this, for the little region around where this precise thing is, we know that the position from satellite X was out by about this much. And so when you collect all those things together, you can start to greatly bring down the accuracy of the satellite position. But then you've got to know, well, how do I get that to the user?
Correct.
That's right.
And you tell someone that they're always off by X. Yeah,
that's right, and that's where an SBAS solution comes in. So there are other SBASs around the world, and they've primarily been brought in for aviation purposes, so help with safety of life of autonomous flying in planes coming into land more safely in airports and things like that.
Nice.
But in Australia, we didn't have enough airports for the use case to stack up just on flying.
We talked about the big hole in the middle of the continent. Sadly, there's the population of people not on the coast in this continent can be measured in 100,000
That's right. So what we did a few years ago was work in partnership with Geoscience Australia and with Land Information New Zealand to get a pilot of this signal going from space. So where we got a communications satellite, we're able to broadcast that correction signal, get some devices down here that could read and understand that, and then we deployed that across 27 different projects, I think, on 9 different application sectors across the economy in Australia and New Zealand, and then did a rigorous approach to look at what was the economic benefit in having this position, this kind of 10 centimeters versus having 3 to 5 meters.
3 to 5 meters radius.
In agriculture, in resources, in navigation applications for the blind, in drones, in augmented reality, all sorts of different applications. And essentially we came out to a figure that I think was around about $6 billion of benefit over the next kind of 10 or 15 years. That was all driven just by having a much more precise location. So the government then used that to get operational funding for that, and that's now a service that's available to anyone really across the Asia-Pacific region to access if they've got an SBAS-enabled device.
Gotcha. So first off, gold star for you. That's phenomenal. Secondly, what kind of device is needed to receive this correction signal as well? Is it beyond consumer products, or is it coming down to that level soon?
It's beyond most consumer products at the moment, although we've got a range of open source kind of examples as to how people can build something. It'll cost kind of $1,000 to $2,000 as opposed to maybe $50,000, which is what it was beforehand to get that kind of accuracy.
Gotcha. Yep.
Saying that, we also have another program that we've been working on with Geoscience Australia, which is called GNAN, which essentially distributes those same corrections but over the mobile network, so via internet connection. And for that, the accuracy is actually better. It's down to around 2 to 3 centimeters.
Wow.
And in theory, we've got that working on Android devices. So we haven't kind of mass marketed that on Android yet, but Android lets you have access to the raw positioning data.
Nice.
So we can correct it here, and we've had that kind of accuracy on Android phones and tablets. Hopefully Apple might do the same kind of access to data at some stage, but
opens API.
But then you have the gaps, in the marine areas, in the areas that don't have internet coverage, you aren't able to get that correction. But anywhere that has mobile reception, we can start to then incorporate that in our daily applications.
Gotcha. Is this a worldwide phenomena? Is this a movement that is going to be coming in the next 2 or 3 years, that it's just a matter of time and pressure and priority?
Ideally, yeah. I mean, there's nothing that stops it working anywhere in the globe except for communications, and most of those accuracy correction services exist in most places around the world. So it's certainly coming more and more. As with any major new capability on, say, a mobile device, you've then got to balance things like, battery performance, because as you can imagine, the compute required to go from what road am I on to where in the lane am I is substantially is a substantial increase. Yeah.
Gotcha. So it's about spheres of influence and how good do I need to be right now. So if you need to be choosing the right lane on the highway, that's kind of neat. And I imagine most GPSs are just guessing. They assume you're on the correct side of the road until you're not, and then politely inform you to come back. Gotcha. So might there be a future where, just as we see World Time Service to, go and check with the world clock or world clocks, would there be World Time GPS ground station correction services as a...
Yeah, absolutely. And like I said, you can commercially buy them in many places in the world at the moment as well. A lot of the driver behind this was to make those even more accurate, but to also make them take away that cost barrier so that the benefits of that kind of accuracy could be available to anybody.
Yeah, Brant, lovely. I was just sadly overseas in a place that I didn't tell my wife till afterwards, was the Worldwide Centre of GPS spoofing. So
yes.
I did note with interest that the plane...
That's another topic entirely that we probably don't have time for.
We don't indeed. That the plane took a very wide route around certain places. That's perfectly fine. Look, by all means, that is a topic we'd love to catch up with later. Phil, thank you so much. Absolute pleasure to have a chat. What a seriously wide range of topics and projects you've been involved with, not only through Frontier SI, but deeper, darker history. Your bio on LinkedIn link be in the show notes, is phenomenal. So there's more to
thank you.
So thank you for that. If you're interested in MapAI, please reach out to Phil. We've got, links to MapAI, and there are, I believe, contact details for you on that website. So follow that through. Just finally, thoughts. Do you think that this year is going to be a groundwater year for language as being the tool of choice? Is that where MapAI is trying to strive for its future customers?
Yeah, look, I hope so. I think if we go back, 15, 20 years, Google Earth and Google Maps was a major explosion in the use of location-based information by everybody.
Yeah.
At the time, I think a lot of people were wondering whether or not it would be a threat or an opportunity, but we've got a lot more demand for spatial applications now that people think about spatial as part of their daily life. Really, I hope that combination of simple kind of chat and large language accessibility combined with location will be the next, major inflection point for how useful location-based information can be around the world.
Absolutely. Look, here, fully support that idea. I guess that's why we're here having a long chat. But Phil, appreciate it. We'll let you get back to your day. And for all those listening, everything's in the show notes. But for now, we'll sign off on this episode of Spatial. So many thanks, Phil, and we'll catch you next time. Cheers.
Thanks. Appreciate your time.
If you'd like more news and insights about spatial AI, or have a story or interesting topic you'd like us to cover, reach out to us. Or better yet, come and join the community at Spatial. All the links are in the show notes.